Hi there, Mr. Boer here with part two for eighth grade online science. We left off talking kind of about covalent bonds and being able to come up with a Lewis structure, a structural formula for doing that. And one of the ways that is described is by using this NASL method of coming up with a Lewis structure. And the N stands for needed, A is available, S is shared, and L is lone pairs. You don't need to know any of that, but it's basically a method for figuring out how to do it. And we'll go through each one. Well, number one, make sure you got a skeleton of what the chemical formula is going to look like. So if we're doing one for H3P, that means three hydrogens and one phosphorus. A says to start with a single element in the center. So if there is a single element, in this case there's three hydrogens and only one phosphorus, put the single one in the middle. So we're going to put P in the middle. If there isn't a single element, use the least electronegative element. You won't have to worry about that until you get up to chemistry. And then one C, you never can use hydrogen because hydrogen is the only one in this whole thing that's a nonmetal that is happy with only two valence electrons. Everybody else wants to have eight. So when we start saying how many does it have available, how many does it need to be happy, hydrogen is the only one that needs two, so it can't bond anywhere else. Once it shares that line, we put a line in between the two, it's already used up its two valence electrons and it's happy. Where phosphorus wants to have eight, so it can bond in a couple of different places, especially if you're only doing a single bond, you can bond in four different places. So there's the N, as I said, determine the number of electrons needed. Atoms want to have eight. That's the octet rule. They want to be like Nobel gases, which already are stable. They have their eight valence electrons, the S and P's filled, all that fun stuff. Hydrogen is the one that's different. It's happy with only two. If you remember when we looked at dot structures, we had top, bottom, right, and left. You got all of them filled in. So that P would be happy with that. H would be happy with only two. The A is how many does it have available? So it wants to have eight phosphorus. Hydrogen wants to have two, but it doesn't have that yet. So it's going to have to do something. It's going to have to share. It's going to have to bond. So phosphorus only has five. Hydrogen only has one, and that's what it's showing you in here. So once I do that, figure out how many bonds there are going to be. That's how many shared electrons there will be. So in order to do that, take the whole molecule, okay, how many it needs to have, minus how many it has available. So if I look at phosphorus, needs eight, hydrogens each need two. So we would have 14, right? Minus how many it actually has. So 14 minus the 5, 14 minus 8 is 6. We divide it by 2. 6 divided by 2 tells me there are going to be 3 bonds. So then you attach those 3 bonds with the elements that are available. And as C is saying the same thing we said before, hydrogen can never bond with anything other than one bond because it's happy with 2. And I said, remember, each line we're drawing represents 2 electrons. So that's how you figure out how many bonds there are. As we move on, and then we got to figure out how many lone pairs of electrons to still put on. Well, everybody needs to be happy. Hydrogens are already happy, so I don't have to do anything, right? And that popped up right there. I'm going to leave it alone for a second. There you go. Phosphorus has to have 8. So if you look around phosphorus, to the right, there's 2 already because it's sharing with hydrogen. To the top, it's got 2 because it's sharing. So we count each line as 2, but that only makes 6. In order for phosphorus to be happy, it has to have 8. So we have to put those 2 lone dots either at the bottom. It doesn't really matter where you put top, bottom, right, and left, all these molecules right now, because a Lewis structure does not show the shape. It doesn't tell us the actual. In fact, this one becomes a pyramid shape. When you get in chemistry, you learn all that stuff. Right now, you just have to be able to draw the picture. So you can check everything. Like I said, is hydrogen happy? Yes. Hydrogen happy? Yes. Hydrogen happy. And now phosphorus, now that I added those last 2, it's happy? Yeah. So there's our Lewis structure for H3P. If I was to do H2O, I would do the same thing. What's your single element? O. So I'm going to put that in the center. And then I'm going to have 2 hydrogens. Well, let's figure out how many bonds they're going to be. Oxygen wants to have 8. Hydrogens each want to have 2. So it's 8 plus 4 is 12. 12 minus, how many does it actually have? 6